Make a wish!
Done!
My wish came true!
Wait, your wish came true? What was yours?
More math! Ah! Whew. All right. So, in this last section of our unit here, we're now going to be... Oh, that's a gross color. We're now going to be factoring multivariable polynomials. So that's just polynomials with more than one variable.
Okay.
So when we're doing this, we actually followed any of the same processes that we did before. So we could use decomp. So if we're looking at this example here, what we would normally do is we'd look for GCS. Obviously there are none in this case. Then we go, okay, well, what's A times C? A times C is 12. Let's look for factors of 12 that add to 8. 6 and 2. So we're still decomposing this middle term of 8xy as 6xy plus 2xy. Same so far. Our next step is we're still doing that partial factoring. So we're still looking at our first two terms and our last two terms and pulling a GCF out of each. So we end up with this second line here. And then last but not least, both of our brackets after we pull out the GCF should be identical, and we could factor that out and be left with our final factored form. So factoring multivariable polynomials might look scary, but really it's just essentially the same thing, but with a different variable involved. So we can even look at this example here.
So in a different way, if you don't really want to do decomp, again, you still don't need to be terrified by the fact that there's multiple variables. Look at how we'd factor this thing that I circled with a highlighter. We have x squared plus 8x plus 12. It factors as this. Maybe that's something that you can get. But that's very similar to how it's factored when there's a y involved as well. Now, it is pretty important that we note the exponents that are happening. So in this trinomial, the x's go with the power of 2, the power of 1, and then nothing over here. And then the y's go with nothing, and then a 1, and then a 2. So when that happens, we can really just ignore that other variable and factor it as if it wasn't there. It gives us this x plus 6, x plus 2, same as on this other side. And then we can just throw that variable back in and say, well, I wasn't actually ignoring it. I was just pretending it wasn't there for my own peace of mind. So we're going to factor a few of these. We encourage you to give them a try, see what you can do, and then compare them to our answers.
All right. Oh, there we go. Come on, Zoom. Oh. All right, I'm going to do this first one through decomp here. So taking a look at this, I can't pull out a GCF. There's nothing that all three terms have in common. So that's kind of done and out of the way. So I'm going to look at A times C. And A times C gives me positive 6. I'm looking for factors of 6 that add to 7, which are 1 and 6. So that's how I know to decompose my middle term. So I have 1xy plus 6xy, and my last and first terms remain the same. Now I'm doing my partial factoring. So I'm going to factor the GCF out of my first two terms and my last two terms. I get x as my GCF, which leaves me with x plus y. And for my second set of terms, I pull out a GCF of positive 6y, and I'm left with x plus y. And again, this is the step where you should be able to acknowledge that you're on the right step because your two brackets should be identical, leaving us with x plus y, and what's remaining as x plus 6y.
Neat.
Yahoo! Woo.
We'll try this other one. And I'll also do this by decomp here. So we're looking for factor pair of negative 40. That adds up to negative 3. So I've certainly got a squared. I'm certainly losing 40b squared at the end. And if I'm thinking of factors of this that add up to that, I'm personally thinking of negative 8 and positive 5. And that's how I'll break that one up. And again, partial factoring of each pair. I've got a common a, leaving with a minus 8b. And I'll take out a 5b, which leaves us with a minus 8b again. So what's common? Well, we've got that a minus 8b showing up both times like a hero, leaving us with a plus 5b.
Heyo, life is good.
It is pretty good.
So these examples aren't too much different here, except in this particular case, when we start factoring, remember, we always look for GCFs first. And here we can see that there is, in fact, a GCF. So I'm always going to pull that out before I start factoring. So I could see in terms of numbers, all of these are divisible by 2. That's their GCF. And in terms of variables, these guys got M's, but the other ones don't. And this has an N, this has 2, this has 3. Heyo, why don't I pull one of them out? So I have the GCF as 2n, which leaves me with 2m squared minus 3mn minus 9n squared. Alright. From here, I'm going to continue on with my decomp as well. So I look at my a times c, which is 2 times negative 9, which gives me negative 18. Factors of negative 18 that add to negative 3. Well, I'm thinking of negative 6 and positive 3. And that's how I'm going to break down my middle terms. Keep in mind that I still need to write that GCF every single time. I'm going to switch to square brackets just to ensure that I see that huge difference, that everything in my decomp step is being contained by those brackets. But the type of brackets doesn't totally matter as long as they are present. So I've decomposed my middle term here. And the next thing I'm going to do in my decomp is I'm going to pull out a GCF of my first two and I pull a GCF out of my last two terms. So when I pull out the GCF of my first two, I have 2m as my GCF, which leaves me with m minus 3n. And then when I pull a GCF out of my second two terms, I have a positive 3n, and I am left with m minus 3n. Nice. Keep in mind here, brackets. You don't want a brackets error, because why would you want to be docked half a mark when you've done everything right? Well, I have 1 opening bracket, 2 opening brackets, 3 opening brackets. I need to have the same amount of closing brackets. 1, 2, I don't have enough. This is why I like to do the square brackets, because I think that helps us acknowledge that they are also necessary. But if you, again, do those soft brackets, no big deal here. Alright, so I still have my GCF. Of my bracketed area here, I can see that both have a m minus 3n in common, and what remains is 2m plus 3n. Huzzah! Woo.
And for our lastest example, oh, too far. There it is. Oh, whoa, fractions, negatives. We're all over the place here. Alrighty. Well, if I'm going to take a look at this, my personal pref is to rewrite it with that common denominator. So I'll do that first. 4 over 4 is equal to 1. Nice. And now I'll do some factoring. I will factor out negative, so we don't have a leading negative, and 1/4 to get rid of that fraction-y fraction, leaving me with 25x squared plus, whoa, psych, that was a test, I passed, minus, because I factored out negative 1/4, where am I at? Minus 20xy. Factoring out negative means this one is plus, glad I caught that, 4y squared. We both caught it. It was a team effort. Now, as we take a look at this, I could start decomping it And when I do so my a times c is 100. Factors of 100 that add up to negative 20 are negative 10 and negative... Oh, same. In that case, if they're same, that means this must be a perfect square trinomial. So, I will keep my negative 1/4. And with it being a perfect square trinomial, I can just tell myself that the first terms must have come from this 25x squared. So that would be 5x and 5x. My other terms must have come from this 4y squared. So I'm looking at 2y and 2y. Are they positive? Are they negative? Well, this negative here tells me that these must be minus signs. And just to double check, because I like to double check my work after I factored, my outside product is negative 10xy. My inside product is negative 10xy. And that does certainly add together to give me negative 20xy. So we are good. And there's that 10 and 10 that we saw before. With that, this one is, in one sense, technically factored, but to finish it off, because it's a perfect square, let's make sure we write that in exponential form as such. If that's all done, then this thing is good.
And that brings us to the end of our unit. So there is some textbook practice there.
Nice.
And whoop.
Well,